Okay, let's do the next one, 20th 2. Okay, that is the function is f of x is equal to x sine x. Okay, x multiplied by sine x. So this also we have to do using the first principle of derivative. Okay, so f dash of x will be limit h tends to 0 f of x plus h minus f of x upon h. Okay, first principle of derivative. So let's do it. So f of x is this, so f dash of x will be replacing x with x plus h. Okay, so limit h tends to 0 x plus h sine x plus h. Okay, this part is over, so f of x x sine x, okay, upon h. Now you see this again resembles the formula, the trigonometric formula, that is sine a plus b equal to sine a cos b plus cos a sine b. Okay, so let's expand this. So it will be limit h tends to 0. Now this as it is, okay, x plus h, this is multiplied with this, so we have sine x cos h plus cos x sine h, okay, minus x sine x upon h. Okay, so we have again, now let's see, this is multiplied with this whole thing. Okay, so you have to multiply this with this, and again the second expression with both of this, so it will be limit h tends to 0. Now first we'll take sine x cos x multiplied with x, so it will be x sine x cos h. Okay, now with h, okay, so plus h sine x cos h. Okay, so this is finished. Now let's take this plus cos x sine x with x, so it will be x cos x sine h plus now h cos x sine h. Okay, so now the remaining minus x sine x, okay, whole upon h. Now we see again, we will remember those theorems of limits, that is x limit x tends to 0 sine x upon x is equal to 1, and limit x tends to 0 1 minus cos x upon x is equal to 0. Okay, so let's bring this to these forms. Okay, now you see sine x cos h, if you take, see, we have x sine x here, we have x sine x here, so if you take this both together, we can take this common x sine x, and h minus 1 will be available. Okay, so let's take this both together first, this and this, so it will be limit h tends to 0 x sine x cos h, and this minus x sine x. Okay, so that part is over. Now we will take next is h sine x cos h. You have another h cos x sine h. Okay, so we have h here together, so let's take this, so we can take h out, so plus h sine x cos h, and this plus h cos x sine h. Okay, so this, we have taken this together. Okay, now this is the remaining, so it will be plus x cos x sine h. Okay, whole upon h. Now let's take commons. See, x sin x and x sin x, we take common here, so it become limit h tends to 0, x sin x is common. Okay, so we have cos h minus 1. Okay, so we are bringing this to this form. Okay, now here you have h here and h here, so let's take h common. H common, you have sin x cos h plus cos x sin h. Okay, take an h common. Now, so this part is over. Now here, okay, this is as it is, x, because you'll see sin h. Okay, now this h, let's distribute this separately to each expressions. Okay, so it can be here h and whole h here and whole h for this. Okay, so now if you see, this is coming closer, cos h minus x upon h coming closer to this thing. So only thing is we have to reverse this. So when we reverse this, it will be minus 1 plus cos h. So we take the negative common. Okay, so it will be limit h tends to 0 negative x sin x, so it will be 1 minus cos h upon h. Okay, and plus, see here, you see this h and h goes out, cancelled. Okay, so you have sin x cos h plus cos x sin h, and here you have, yeah, same thing, cos x cos x sin h upon h. Now let's distribute this limit also to each expression. So this will be limit h tends to 0. So we can bring, if you need, we can bring this thing out of the limit. No, we'll do it like this only. Minus sin x 1 minus cos h upon h plus limit h tends to 0 sin x cos h plus cos. Okay, here also we'll just we'll write limit. Okay, limit h tends to 0 cos x sin h plus limit h tends to 0 x cos x sin h upon h. Okay, that's it. Now you see 1 minus cos h will be 0, and here sin h upon h, this will be 1 according to the theorems. So limit h tends to 0, this will be 0. Okay, so we get minus x sin x multiplied by 0, and putting the value of h in this, you get sin x cos 0. Okay, here h we put 0, so plus, and again here cos x, we put the value of h in sin, so it becomes, h becomes 0, plus this whole thing becomes now 1, so it becomes x cos x multiplied by 1. Now this is 0 upon anything 0, plus cos 0 degrees, cos 0 is 1. Okay, cos 0 degrees is 1, so sin x multiplied by 1 plus sin 0 degrees 0, so this whole thing becomes 0. Okay, so this is 0 again, sin 0 is 0 into this thing is 0. Now plus x cos x. Okay, cos x into 1 is x cos x. So you have, what do you have, sin x and plus x cos x. Okay, that's it. This is the answer. Now when solving this, the normal method, by the normal method, that is f of x is equal to x sin x. Okay, f of x is equal to x sin x. Now d by dx, by normal method, when you do is this, we have to assume this has two functions, and this has u and this is v. Okay, so u dot v whole dash will be u dash v plus uv dash. Okay, this was a formula. Okay, so d by dx of f of x is equal to d by dx of x sine x. So this is u and v. Okay, so u dash, so x dash and v as it is sine x plus u as it is, that is x, and v dash sine x. The derivative of sine x is cos x. Okay, we'll write sine x whole dash. Okay, so this will be 1. The derivative of x will be 1 multiplied by sine x plus x, and the derivative of sine x is cos x. So we have sine x plus x cos x. Okay, that's it. The same thing. This is how we do. Okay.